Welcome to a new course on my channel. In this course we will make a small website using Laravel and React. To start this course you need to know a little bit of Laravel and React, at least the basics, because I will explain everything we do in this course, so it is fine if you are not advanced in those topics. The course is just for us to learn how to make a small website using React and Laravel and how to connect them together. We will make APIs using Laravel and then we will call them using Axios in React and make a small UI for them. Now let's demo our website. First, this is the login form and the register form. Next, let's create a new account and we will be inside the website. There is the name of our account and the logout button. Next we will go to the users page and inside of it there is a table with all the users that we have. We can press the edit button to update a user, and the add new button to create a new user, and there is a delete button to delete the user. It is a small website just to learn how to make authentication and CRUD operations using Laravel and React, and maybe in the next course we will make a bigger website with bigger functionalities. Now let's start creating our website. First we will make a new Laravel project using Composer create project command. And now after the project is created, let's go inside of it and name our database as we want. Next we will go to our PHP My Admin database and make our database with the same name that we wrote in our env file. Next we will go back to our application and migrate the database tables. We will use the PHP artisan migrate command, and our tables are migrated and everything is working fine. Next we need to make our React application, and we will use Vite with it. But what is Vite? Vite, which means fast in French, lives up to its name by offering blazingly fast development and build times. But how does it achieve this lightning speed? Well, let's break it down. Unlike traditional bundlers like Webpack, which rely on bundling and transpiling every dependency in your project, Vite takes a different approach. Instead of bundling all your code up front, Vite leverages modern browser capabilities like ES module, ESM, imports to serve your code directly to the browser during development. This means that instead of waiting for the entire application to bundle before seeing changes reflected in the browser, with Vite, you get near instantaneous updates as you code. No more waiting around for Webpack to do its thing. But that's not all. Vite also supports a variety of modern technologies out of the box, such as JSX, TypeScript, CSS modules, and more. Plus, it integrates seamlessly with popular frameworks like React, Vue, and Svelte, making it a versatile choice for your development needs. Furthermore, Vite comes with a built-in development server that supports hot module replacement, HMR, allowing you to see changes reflected in real time without losing state. This makes for a smooth and efficient development experience, whether you're working on a small project or a large-scale application. In summary, Vite is a next-generation build tool that prioritizes speed, efficiency, and developer experience. By leveraging modern browser capabilities and embracing the principles of incremental development, Vite empowers developers to build better web applications faster than ever before. Now let's make our React application using Vite. We will use this command and let's follow the instructions. Now after we have created our React application, let's run it using npm run dev. And we will get this page with a small counter, and that's great. Now let's start our real work. Let's first go to our React application, which is located inside our Laravel application, and let's delete some things that are installed with it. Next we need to install React Router DOM. What is the React Router DOM? React Router DOM is a popular library for managing navigation and routing in React applications. It allows developers to create dynamic, single-page applications with multiple views, all while maintaining a clean and intuitive user experience. Now after that, let's make a new folder called View, and inside of it we will put our views files. First we will make the login view and the register view. Then let's make a file called router. What will this file do? The primary purpose of a router file is to serve as a centralized location for configuring routing within a React application. This file typically imports the necessary routing components and defines the routing configuration for the entire application. It defines the routes, handles navigation, and ensures that the correct components are rendered based on the URL path. By centralizing routing configuration, it helps maintain a structured and organized approach to navigation within the application. The browser router component acts as the root of your application's routing functionality, while root components define the mapping between URLs and React components. With React Router DOM, you can easily define routes for different views and handle navigation between them seamlessly. Now inside of it we will make two new paths for the login and for the register. We need two elements. First the path, which is the URL that we need to access to get to that element, and the second is the element. So that means when we go to the URL login we will go to the login view and render that page, and we will do the same thing for the register view. Next we need to go to our main file and add the router. But what is happening here, and what is the React strict mode? It is a built-in React component that helps identify potential problems in your code and highlights them in development mode. It doesn't render any visible UI itself but activates additional checks and warnings for child components and their descendants. It's primarily used during development to catch and highlight potential issues such as deprecated lifecycle methods, unsafe component lifecycles, and legacy APIs. It helps you write cleaner and more reliable code by providing helpful warnings. By wrapping your application components with Router Provider, you're making the routing functionality available throughout the application. This allows you to use routing features such as navigating between different views or rendering components based on URL paths. Overall, it initializes the routing functionality using Router Provider, possibly from a router library like React Router, and ensures stricter development checks and warnings using React strict mode. This helps in building robust and reliable React applications with enhanced debugging capabilities during development. Next, let's make a small login and register views just so we can make sure everything is working just fine. We will just make the login function and make it return a div with the word login, and we will next do the same thing for the register view. Now let's run our application using npm run dev and go to the login page, and we will get an empty page, so there is a problem with our routing. The element shouldn't start with a small letter and also the import, so let's fix them and try again. And we will get our register page and our login page just like we want. So now we made sure our routing is working just like we want it to. Now let's make a new folder and call it components. Inside of it we will make two files, one default layout, and the second called guest layout. Let's make a small return div inside of them, so let's copy the code from the register and make it for them. And I will explain what we will do with them while I write the code. In many React applications, especially those using React Router for navigation, it's common to have a default layout component. This component serves as a template or wrapper for other components, providing a consistent layout and structure across different pages of the application. Why we use a default layout component? By using a default layout component, we ensure that all pages of our application have a consistent look and feel. This improves user experience and makes navigation more intuitive. Instead of duplicating layout code in every page component, we centralize it in the default layout. This promotes code reusability and makes maintenance easier. The default layout component can be customized to accommodate different design requirements or user interface elements. This flexibility allows us to adapt the layout as needed without modifying individual page components. With a default layout component, navigation-related elements such as headers, footers, or sidebars can be managed centrally. This simplifies navigation logic and reduces the complexity of individual page components. In conclusion, the default layout component in React Router plays a crucial role in providing consistency, code reusability, flexibility, and simplified navigation in our applications. By centralizing layout logic and structure, it helps create a cohesive user experience and streamline development efforts. Now let's make a users file so we can make the users view later. Now let's go to our router and add all the new routes. In React Router, the term children refers to nested routes or components within a parent route. When defining routes using React Router, you can specify routes as children of other routes, creating a hierarchical structure for navigation within your application. When a route has children defined, it means that those routes are nested under the parent route. This nesting can be visualized as a tree-like structure, where each parent route can have multiple child routes associated with it. So what are the benefits of using children? Children routes allow you to modularize your application's routing configuration. Instead of defining all routes at the top level, you can organize them hierarchically based on their relationships. By nesting routes as children, you can create complex navigation structures that scale well with your application's growth. This makes it easier to manage routing in large applications with many different views and components. Children routes can also be used to implement route guards or middleware logic. You can define common behavior or checks at the parent route level, which will apply to all child routes nested under it. In summary, the concept of children routes in React Router allows you to create hierarchical navigation structures and modularize your application's routing configuration. By nesting routes as children, you can create scalable and maintainable routing solutions that enhance the user experience and development process. Now we will learn something that is called outlet we need to use inside our guest and default layouts. What is this outlet? A placeholder component used in React Router for rendering child components or routes. It serves as the insertion point for child components defined within the parent route's configuration. When a parent route component, such as the default layout component in this case, is rendered, it may contain nested child components or routes. The outlet component within the parent route's JSX acts as a placeholder where these child components or routes will be rendered. React Router dynamically renders the appropriate child components or routes defined under the parent route and inserts them into the outlet component's location within the parent's DOM structure. It allows for dynamic rendering of child components or routes within the parent route's layout. This enables the creation of flexible and scalable routing solutions. And by using outlet, the layout component remains agnostic of the specific child components or routes it renders. This promotes a clear separation of concerns between layout and content. In summary, outlet in the default layout component serves as a placeholder for rendering child components or routes defined within the parent route's configuration. It allows for dynamic rendering of content while promoting separation of concerns and facilitating the creation of flexible routing solutions in React Router. Now let's run our application to test everything, and we got an error in our default layout file. We forgot to import the outlet from the React Router DOM. So now let's try again, and everything is working fine, and if we go to the login page we will get guest login, and that's what we want. Now let's try and go to the users page, and we will get default users. So now the default layout and guest layout are working just fine. Now let's make our context folder so we can start our real work inside of it. Inside the context folder we will make a new file and call it context provider. At its core, state context is created using React's createContext function. This is the first step in establishing a global state that can be accessed across different components without the need to prop drill. Let's break down the initial structure. Here, createContext is called with an initial object. This object contains two properties, user and token, both initialized to null. But why these two? The answer lies in their universal importance. The user property is intended to store user information, typically set after a successful login operation. It could include the user's name, email, or any other identifying data crucial for user experience customization. The token, on the other hand, is all about security. It's the authentication token received upon logging in, acting as a key to access protected routes and resources. By storing it in our context, we ensure that it's readily available for securing API requests and managing session states. Once state context is established, it becomes a beacon of data for components deep in our application's hierarchy. Components can subscribe to this context and react dynamically to changes in user information or authentication status, fostering a cohesive and responsive user experience. The context provider serves as the cornerstone of our state management strategy. It wraps our application's component tree, allowing every child component to access the state without prop drilling. Notice how it accepts children, a prop representing the child components that context provider will wrap. This design enables any level of the component tree to access the shared state. Within context provider, we manage two crucial pieces of state, user and token. User is initialized as an empty object, ready to store user details, and token fetches the authentication token from local storage, ensuring persistent login sessions. We also provide a setter function for the token to not only update its state but to interact with the browser's local storage, adding or removing the token as needed. The setToken function plays a dual role. When a token is present, it's stored in both the state and local storage. This ensures that the user remains authenticated across sessions. Conversely, when logging out, this token is removed from both the state and local storage, securing the user's session. The magic happens when we use state context provider to pass down user, token, set user, and set token to the entire component tree. This pattern ensures that any component, regardless of its depth, can access and manipulate the user state and authentication status effortlessly. To access our context easily, we export useStateContext, a custom hook that taps into state context using useContext. This abstraction simplifies the consumption of our context, making it more intuitive for developers to integrate state management into their components. And we forgot to add set user and set token in the state context, so let's add them. Next, let's go to our default layout. The default layout component plays a pivotal role in our application structure. It acts as a guardian, deciding which parts of our application are accessible to users based on their authentication status. First, default layout taps into our global state using the useStateContext hook. This hook grants us access to the user's authentication token and other user details, enabling us to make informed decisions about what the user can access. By destructuring token from our context, we can easily check if the user is authenticated or not. The core functionality of default layout revolves around this simple yet effective check. If there's no token, meaning the user is not authenticated, redirect them to the login page. It's an elegant way to protect our application's roots, ensuring that only authenticated users can access certain parts of the app. The Navigate component from React Router plays a crucial role here. It programmatically navigates the user to a different route, in this case, login. This redirection is smooth and instantaneous, enhancing user experience by guiding users to where they need to be. Next, the Guest Layout component is designed to handle pages that are primarily intended for unauthenticated users, such as the login and registration pages. Its main task is to check whether a user is already authenticated and, if so, to redirect them away from guest-only pages. To perform its critical check, Guest Layout makes use of the useStateContext hook. This hook provides access to our global state, including the authentication token, allowing Guest Layout to make decisions based on the user's authentication status. So here we say if there's an authentication token, redirect the user to the homepage. This ensures that authenticated users are not navigating or stuck in the guest areas of the application. Now let's run our application to test everything. And we got some errors. Here there is two problems. First, we wrote the default layout function wrong, and the second is we have a problem with our import. The contexts folder starts with a small letter, not a big one, and we also forgot to add the imports to the guest layout, so we got an error there. Now after we have fixed everything, we can see that our application is working just like we wanted it to, and that's great. Now we can't access the users because we don't have an access token. Let's go to our context provider and try to add an access token. And then let's go to our main app and add make the router inside our context provider, and now we can go to our application and try again. And we will go to the default layout. And if we try to go to the login page, we will be redirected to the default layout because there is an access token, and that's what we want. And then if we go back and remove our access token, we will go to the login page and we cannot access the default layout or the users page anymore. Now let's go the index CSS and paste the code of our styles. I will not write them, I will just paste them because they are too long and easy to write. There is a link in the description for the whole project and you can find the CSS file in there and copy it. Next, after we have made our CSS file, we will go to our default layout and start making our UI. We will make a div with the class name content, and inside of it we will make a new header. Now let's go to and see it, but first we need to add an access token so we can access the default layout. And we will, and after that we will get our header with the user info and header words. Now let's add to the users a name and call it John for example, and try to access it in the default layout. To do so we will just use the user and then dot and then name, and now we will get the name that we put, which is John. Let's try and see it. And we got John just like we wanted, and that's great. We now know how to pass data in our views. And let's add a link for the logout button to put next to the name of the user, and later we will write the logic for it. Next, let's make the login view. We will use the styling from the index CSS using class name, and we will make a new form to submit our data. we will need an email and password, and let's make the on submit and leave it empty for now. And let's in the end of the form add a button if the user doesn't have an account and with the link to take it to the register form. Now let's remove our access token and go and try the login form and see how it looks. And it looks great. Let's just remove the word guest from the guest layout. And if we press the link in the end of the form, it will take us to the register page, and that's great. Now let's make the design a little bit better and add a header for the form that says log into your account. Next, let's copy the login UI and paste it in the register form and edit a few things. Let's change the title of the form, and add a name field, and let's change the link down below to take us to the login form. And let's also copy the on submit and the imports that we need. Now let's go and try them, and the two forms are working fine and with the design that we want, and that's great. Now we need to make the logic for the authentication. We will need to use Axios for that. We will install Axios using npm install Axios command. But what is Axios that we are installing? In the realm of web development, making HTTP requests, whether it's fetching data from a server or sending data to an API, is a fundamental task. This is where Axios steps in. Axios is a promise-based HTTP client that enables us to make HTTP requests. You might wonder, why not just use the built-in Fetch API in JavaScript? While Fetch is powerful in its own right, Axios offers several advantages that make it a preferred choice for many developers. But what are those advantages? Axios provides a simple and intuitive API for making HTTP requests, with methods like Axios GET, Axios POST, Axios PUT, and Axios DELETE, making it easy to understand and use. Axios is built on promises, allowing for cleaner asynchronous code with straightforward error handling using then and catch. Axios automatically parses JSON responses, saving us the extra step of manually parsing the response data. Axios supports interceptors, allowing us to intercept requests or responses before they are handled, enabling tasks such as adding headers or transforming data. So now, after we have understood what Axios is, let's make a file called Axios Client and use it inside of it. Now what will we write in this file? First, in its simplest form, Axios Client is configured with a base URL that serves as the starting point for all API requests. Here's how it's done. By setting the base URL to our API's endpoint, we establish a centralized location for sending and receiving data, streamlining our API requests. One of the most powerful features of Axios Client is its ability to intercept requests and modify them before they're sent. This comes in handy, especially for handling authentication tokens. Here, we're intercepting each request before it's sent, retrieving the authentication token stored in local storage, and adding it to the request headers. This ensures that authenticated requests are properly authenticated, keeping our application secure. With Axios Client by our side, making API requests in React becomes a breeze. Its simplicity, flexibility, and powerful features streamline our development process, allowing us to focus on building robust and dynamic applications. In the realm of HTTP requests, errors are an inevitable part of the process. Axios Client comes equipped with response interceptors, hooks that allow us to intercept and handle responses from API requests before they reach the application. When a response is successful, Axios Client's response interceptor swings into action. It captures the response and passes it through to the application, ensuring seamless data retrieval. The success handler simply returns the response as is, allowing it to flow through to the application without any modifications. But what happens when things don't go as planned? That's where Axios Client's response interceptor shines. It intercepts error responses and provides us with an opportunity to handle them gracefully, ensuring a seamless user experience even in the face of adversity. Axios Client checks if the response status code is 401, indicating an unauthorized error. In such cases, it removes the user's access token from local storage, effectively logging them out and safeguarding their security. Finally, Axios Client ensures that errors are propagated back to the application, allowing developers to handle them appropriately. This enables us to display error messages, initiate retries, or take any other necessary actions based on the nature of the error. Now let's go to our register and add some variables. These variables are created using the useRef hook, which is a built-in React hook used to create a mutable reference to an element or a value that persists across rear-enders of the component. Name ref, email ref, and password ref are being used to reference the input elements in your registration form. This allows you to access and manipulate the values entered by the user without directly querying the DOM, which is one of the main advantages of using useRef in React. So why do we use that? By creating references to input elements using useRef, you make it easier to access and interact with them programmatically. This is especially useful when you need to focus an input field, retrieve its current value, or programmatically trigger a form submission. In the context of a registration form, name ref, email ref, and password ref likely refer to the input fields where users enter their name, email, and password, respectively. These references allow you to access the current values of these input fields when the form is submitted, enabling you to send this data to the server for registration. Next in the onSubmit, let's make a new const and call it payload and put the name, email, and password values inside of it, and then let's console log the payload. Let's go to our register form and try to add a name, email, and password, and then let's go to our console. And we will find the data that we have, and that's great. And now let's add our Axios client and the set user and set token, and I will explain everything in the submit function. In our submit function, we first prevent the default form submission behavior using prevent default. This ensures that the page doesn't reload when the form is submitted, providing a smoother user experience. Next, we construct a payload object containing the user's name, email, and password. We retrieve these values from the input fields using the name ref, email ref, and password ref references created earlier. Now comes the exciting part. We use Axios client to make a post request to our server's register endpoint, sending along the payload we just constructed. Upon receiving a response from the server, we handle it accordingly. If the registration is successful, the server responds with data containing the user object and authentication token. We extract this data and update our application state using set user and set token, ensuring that the user is logged in and their details are up to date. But what if something goes wrong? Fear not. We've got error handling in place. If the server responds with a 422 status code, indicating validation errors, we log the errors to the console for debugging purposes. And there you have it, the submit function in our registration component, a crucial piece in the puzzle of user registration in React. By leveraging the power of state context and Axios client, we've created a seamless registration experience for our users. And after we have finished this, we need to start making the APIs for our project. We will start by making a new controller using PHP Artisan make controller and name it Auth controller. Now let's you inside our Auth controller, which is located in the app, HTTP, controllers folder. Inside of it we will make three functions. The first one is the login function, the second one is the register function, and the third is the logout function. The login and register will take login request and register request as an argument, and we will now make the requests files. But why did we do this and separated the requests from the controller? Separating requests from controllers aligns with the principle of separation of concerns. Controllers are responsible for handling business logic, while requests encapsulate the validation rules and data transformation specific to incoming requests. Now let's go to our API routes and add the login and logout routes. After we have registered our routes, let's go to the auth controller and start by making the register function. First, the register function receives a register request instance, which encapsulates validation rules and authorization logic. The validated data is retrieved using the validated method. A new user is created in the database using the validated data, with the password hashed for security. A token is generated for the newly registered user. Finally, a JSON response containing the user and token information is returned. Next, let's make the login function. This function is responsible for validating user credentials, authenticating users, and generating authentication tokens for subsequent requests. The function receives a login request instance, which encapsulates validation rules for email and password fields. The validated data is retrieved using the validated method, ensuring that it adheres to the defined validation rules. Laravel's built-in auth attempt method is used to attempt user authentication based on the provided credentials. If authentication fails, an appropriate error message is returned to the client. Upon successful authentication, the authenticated user instance is retrieved using auth user. A token is generated for the authenticated user using Laravel's Sanctum's createToken method. Finally, a JSON response containing the authenticated user and authentication token is returned to the client. Error handling is a crucial aspect of the login function. If authentication fails due to incorrect credentials, the function returns an informative error message, allowing clients to take appropriate action. Next, we will make the logout function. It will be a small function. We will just get the user from the request, and then we will get the current access token and delete, and then we will return an empty response after that, and that's it for our auth controller. Now we need to make our login and register requests to handle form validation. First, we need to make the authorize true, and then in Laravel, validation rules are defined using the rules method within request classes. This method returns an array of validation rules that govern the format and content of incoming request data. Name, The name field is required and must be a string with a maximum length of 255 characters. Email. The email field is required and must be a valid email address. Additionally, it must be unique within the users table, ensuring that no two users share the same email address. Password. The password field is required and must adhere to certain criteria. It must be at least 8 characters long and contain at least one letter. By enforcing these validation rules, Laravel ensures data integrity within registration forms. Users are prompted to provide accurate and properly formatted information, reducing the risk of errors and inconsistencies in the database. Next we will go and make our login request rules. Let's just copy the register one and delete the name, and remove some of the rules because we don't need them, and that's it for our login and register requests. Next let's run our application from the backend and frontend to test it, and let's try and make a new user to see if the register is working, and we are getting a problem and we don't know from where, so let's make a try catch in our Axios client to know where the error is from. There is a problem with our users table. Let's specify the table in the model. And let's edit the rules of the register and make the table name users not user. Now let's go and try again. and we got a new error. Let's check our roots and they are all post, so the problem is not from the roots. We have forgot to add a slash to the register, and then now let's go and try again. And the register form is working fine and everything is just like we want and we are inside. Now let's open a new private window to test it again because we haven't added the logout yet, and the register is working fine. Now let's make our login logic. It will be the same as the register, so let's just copy it and paste it in the login and edit the endpoint and remove the name, and then let's go and try it, and we are logged in and everything is working fine. Now let's open our console and type local storage clear, and now our access token is removed. Let's try and log in without the password to test our validation. And we will get an error message because of that, so our validation is working fine. Now let's try and add a password. And we are logged in and that's great. Now we need to edit the name that is popping up in the header to be the user's name. We already have an API for this, so let's use it. Let's first delete the name John that we already have and then go to our default layout. We will make a new use effect and we will use Axios client get to access the API, and we will put the data in the set user. And then let's put the set user in the const, and now let's go and try to login. And we will get the name of the user that is logged in, and that's great. Next let's make our logout use effect. we will copy the same code and just edit a few things, and we will set the user to null and token to null, and we will add the set token to the const. Now let's go and try the logout that is located in the header, and we will get an error. So let's go to our roots and edit the logout method to get, because we are not sending any data. And then let's try again. And we got another error, and that is because the logout function should be inside the auth middleware. So let's add it and try again. And we will be log out of the application and everything is fine. But now, after we made sure that it is working, let's go and make a middleware group so the code would be cleaner, and put the user and logout inside of it. Now let's go and make our users view. First we will make to const users, an array to store user data retrieved from the server. Loading, a Boolean flag to indicate whether data fetching is in progress. To fetch user data from the server when the component mounts, we utilize the useEffect hook. By passing an empty dependency array, we ensure that this effect runs only once after the initial render. The getUsers function is responsible for fetching user data from the server. Here's how it works: it sets the loading state to true to indicate that data fetching is in progress. It sends a GET request to the user's endpoint using Axios. Upon successful response, it updates the user's state with the received data and sets loading back to false. In case of an error, it sets loading to false without updating the user's state. Error handling is a crucial aspect of data fetching. In case of any errors during the request, the catch block sets loading to false, ensuring that the loading state is accurately reflected in the UI. By managing the loading state throughout the data fetching process, we ensure that the UI responds appropriately to indicate when data is being loaded and when it's ready for display. This enhances the user experience by providing feedback and preventing confusion. Now we will make the APIs of the users. First we will make a new controller called user controller, and we will add resource and model user and requests to it. So now Laravel will create the functions for it with the requests for the functions that needs requests. So now let's delete the functions that we don't need. And then let's make a new resource called user resource. Now what does this resource do? In Laravel, a resource is a class that transforms models or collections of models into JSON representations. It acts as an intermediary between your application's data and its presentation layer, allowing you to customize how data is formatted and structured before being sent to clients. T defines the data structure of the JSON representation of a user. In this example, it includes the user's ID, name, and email fields. By customizing this method, you can control exactly which data fields are included in the JSON response, as well as their formatting. So why do we use this? Resources allow you to tailor the presentation of your data to suit the needs of your application or API. By centralizing data formatting logic within resource classes, you ensure consistency across your application's JSON responses. Resources can handle complex data transformations, such as including related model data or computed attributes, providing flexibility in data presentation. Now let's start writing in our controller. The index method is responsible for listing existing users. Retrieves all users from the database using the user model. The results are ordered by ID in descending order, ensuring that the most recently added users appear first. Finally, the collection of users is transformed into a JSON response using the user resource collection method. Next up, we have the store method, tasked with creating new users. It receives a store user request instance, which encapsulates validation rules for creating a new user. The validated data is retrieved and manipulated as needed. In this case, the password is hashed using Laravel's bcrypt helper function. A new user record is created in the database using the create method of the user model. The newly created user is transformed into a JSON response using the user resource class, providing a clean and structured representation of the user data. The show method retrieves and displays details of an individual user. T receives a user instance as a parameter, automatically resolved by Laravel's root model binding. The user data is transformed into a JSON response using the user resource class, providing a structured representation of the user's details. Next, we have the update method, tasked with updating user information. It receives a update user request instance, containing validation rules for updating user data. The validated data is retrieved, and if a password change is requested, it's hashed using Laravel's bcrypt function. The user's information is then updated in the database using the update method of the user model. Finally, the updated user data is transformed into a JSON response using the user resource class. Last but not least, we have the destroy method, responsible for deleting user accounts. T receives a user instance as a parameter, automatically resolved by root model binding. The user's record is deleted from the database using the delete method of the user model. A 204 no content response is returned to indicate that the deletion was successful. Next, let's register our routes in the API file. We will use root resource to do so, and we will put it inside the auth middleware. Next, let's go and put the rules of our requests just like the login and register. And now after we have added our rules, let's go and make our user form view to make a form to add a new user inside of it or update an existing user. Let's make a new function called user form and then go and register our new page in the router. We will make two pages for it. New user form. This route is accessed via users new. It renders the user form component, allowing users to create new user entries. Update user form. This route is accessed via user's ID, where ID represents the unique identifier of the user being updated. It also renders the user form component, enabling users to update existing user information. Notice how the element prop within each route configuration dynamically renders the appropriate user form component based on the route path. By leveraging React Router's dynamic routing capabilities, we can create a seamless navigation experience for users. Each user form component is assigned a unique key prop, user creation form, keyed as user create, user update form, keyed as user update. These keys help React efficiently manage component state and ensure proper rendering when navigating between different user forms. Now let's go to our users view and add a link to take us to the users form page to create a new user. Now let's go and test it. Let's log in and go to the users page. But we got an error because we forgot to import the Axios client, so let's import it and try again. And we will get our link, and when we press it we are going to the user form, so everything is working fine. Now I will just paste the code for the UI because it is too long, and I will explain it, and the code is on GitHub if you want. I have added a link down below. The interface gracefully handles loading states, displaying a loading message when user data is being fetched from the server. This ensures that users are aware of ongoing operations and prevents confusion or frustration. Once user data is retrieved, it's dynamically rendered within the table. Each user's ID, name, and email are displayed in separate table cells, with corresponding actions, edit and delete, provided as interactive buttons, and there it is. Now let's see the onDelete click. The onDelete click function is invoked when a user initiates the deletion of a user account. Let's break down how it works. Before proceeding with the deletion, a confirmation dialog is displayed to the user. This ensures that users are aware of the action they're about to take and helps prevent accidental deletions. If the user confirms the deletion by clicking OK in the confirmation dialog, the deletion process continues. Otherwise, if they click Cancel or close the dialog, the deletion process is aborted, ensuring no unintended actions occur. Once the deletion is confirmed, an API request is sent to the server using Axios, the HTTP client for making asynchronous requests in React applications. The request targets the specific user's endpoint for deletion. Upon successful deletion of the user account, the getUsers function is invoked to refresh the user data displayed in the interface. This ensures that the list of users accurately reflects the changes made. Now let's try and delete a user. We will press the delete button and we will get the message that we wrote, and then let's delete the user, and the user is deleted from the table. Now let's make the add new page to add a new user. We will go to the user form and copy a few things from the user's file. In the set user we will add ID null and we will add the name, email and password and leave them empty. Then if there is an ID, I will paste the code for it and explain it. This ID signifies whether we're embarking on a quest to edit an existing user. If ID exists, our saga to fetch user data commences. Enter the useEffect hook, a spellbinding feature of React that allows us to perform side effects in our function components. By invoking useEffect, we ensure our data fetching ritual only begins once, right after our component mounts, preserving resources and enhancing performance. Then Axios take center stage, sending a request to the distant lands of our server, seeking the data of the user with the specified ID. It's a journey fraught with anticipation as we await the return of our data. Upon the successful return of our data, the darkness of loading lifts. Our user's data is now in our grasp, ready to be wielded in the form, painting the story of their journey so far, allowing us to rewrite their future. But what of unforeseen storms, where data fails to return? Our saga accounts for such trials, ensuring that, even in failure, the tumult of loading ceases, and calm is restored, allowing for corrective action. Next we will add setErrors to handle errors in the form, and after that we will paste the code of the form and explain everything. Now I will paste the form code and explain it. First, let's talk about conditional rendering. Our component uses the user object's ID property to determine the form's purpose. If the ID exists, it means we're updating an existing user, otherwise, we're creating a new one. This logic is beautifully simple but incredibly powerful, allowing us to use the same form for two different operations. Next, we have the loading state. In web applications, responsiveness and feedback are crucial. Our form component gracefully handles loading states by displaying a loading message when the application is fetching data or processing the form submission. This immediate feedback improves user experience by informing users that their request is being processed. Error handling is another critical aspect covered by our form. When errors occur, such as validation errors from the server, our component maps over these errors and displays them to the user. This feedback is essential for improving user interactions, allowing users to correct their input based on specific feedback. The heart of our component is the form itself. We have inputs for the user's name, email, and password. Each input field is controlled, meaning its value is tied to the component's state, and any change to the input updates the state accordingly. This pattern is a React best practice for form handling, ensuring the UI and the data are always in sync. Next let's paste the onSubmit function and explain it. The onSubmit event handler is triggered when the form is submitted. It performs two primary actions based on the condition, if we're editing a user ID exists or creating a new one. This adaptive behavior is crucial for a reusable form component. The first line within our function prevents the default form submission behavior using event prevent default. This is a standard practice in React to stop the form from reloading the page, allowing us to handle submission asynchronously. Next we use a simple if-else statement to distinguish between update and create operations. This decision is made by checking if user.id is present, indicating an update operation. For updates, we make a put request using Axios to the specified endpoint, passing the updated user data. This request is sent to our backend server, which processes the update operation. For creating a new user, a post request is sent instead. This request carries the new user data to be processed and stored by the backend. On successful completion of either operation, the user is redirected to the user's page. This redirection is handled using the navigate function from React Router, providing a seamless user experience by showing the updated list of users immediately. And then there is the error handling for our submit function. Error handling is a critical part of any form submission. Our function catches any errors that occurred during the request. Specifically, it looks for validation errors, HTTP status code 422, and updates the component state with these errors. This state is then used to inform the user about what needs to be corrected. Now let's go and try everything. Let's go and try to add a new user. And there is our user form, and the new user is added to our table, and that's great. Now let's try to update our user, but when we are trying to update we are getting the wrong form, so let's go to our user resource, the wrap false. And then let's go and try again, and we will get the user update form. Now when we try to edit the user we will get an error after the submit, and that is because we forgot to add s to the user endpoint. So let's edit it and try again. And everything is working fine. And that's it for our course. I hope you enjoyed it and understood everything. If you have any questions, add a comment down below, and if you want to support the channel, check the Buy Me a Coffee link down below. It really helps me keep making free courses like this. Thank you for watching and see you in the next course.